like to start off by acknowledging the traditional owners on all the lands and the homes and the houses that we're meeting together today. Always was, always will be. Treat it with respect. This is a webinar to get the model releases of the ACCESS-CM2, the new state of science physical model of ACCESS, and ACCESS-EMS1.5, our first ever Earth system model submission, and both to CMIP6. And Chloe, if you just jump to the second slide. That's basically the order we'll be going through. Martin will be presenting on ACCESS-CM2. Tilo will give us an overview of ESM1.5. Very happy to have Holger joining us from Monash and CLEC's computational modelling support team. Today, he'll be talking us through operation of the ESM1.5 as supported by the CLEC CMS. And then Chloe will finish up giving us an overview of the CMIP6 datasets that we've been producing over the course of the last year and more. If you want to request the floor to ask a question, type a exclamation mark into the chat function. I'll try to keep monitoring it, or you can ask questions directly into the chat function, and some of us from the NESP project will be able to answer questions as we go through the meeting. So that's about all I had to say to get us started. Thanks for joining us. Hopefully there's some new ACCESS users out there who are looking to learn, and we've got systems that can be learned. It's not just this webinar. You can always get back to us later and ask us, get in contact for more assistance. We'd be delighted to assist new users of the ACCESS models. So with that said, we'll hand it over to Martin to start things off. And I think Martin would like to share his screen.
Okay, can you see that?
That's all good, Martin. Yep, full screen.
It was the end, not the start. Okay, so I'm going to give you an introduction to running ACCESS-CM2. So first, ACCESS, as you probably all know, has been a sort of a national effort for the last 15 years now on the Australian community model for both weather and climate. The atmospheric component is the Met Office's UM. The ocean component is the NOAA MOM. We've also got a chemistry component from UKCA, which is a UK consortium. We have a sea ice model from Los Alamos, and we have the Australia's own cable land surface scheme. So that means we're dependent on a whole bunch of both international and local collaborators to make this all work. We've had a lot of support from the old ARC Centre for Climate System Science and currently CLECs on both the land, surface and the ocean work. So we're very grateful for that. And of course, a lot of support from NCI on the computational side. And you can see there in the middle the components of the model. The land carbon and the ocean carbon aren't included in ACCESS-CM2, though they are included in ESM, which Tilo will be talking about later. So the modelling environment at NCI, we run on Gadi, the peak system. Typically, the model runs on about order of 1,000 cores. All the initial conditions, the ancillary files and the pre-built libraries, etc., are in a special ACCESS user account, and to be able to use that, you need to be a member of the ACCESS group at NCI. So if you're not a member, you just need to apply for that through the normal NCI Mancini system, and we'll add you. And that will give you access to everything you need to run the model. So all the files are under that account. We've tried to move everything. There should be nothing that depends on sort of CSIRO P66 projects and things like that. The other important aspect of the whole thing is the NCI Cloud Machine ACCESS-Dev. This is the front end for running CM2, where you run the row silk suites for model suite control. It also provides some web services, a track system for the documentation, which we'll see later. And that's collaboratively managed by people from CSIRO, CLEX, BOLM and NCI. And we also depend on an ACCESS SVN repository, which those of you who've used older versions of the model will have used, and that's also used for some of the other code repositories that CM2 depends on. The CM2 configuration. The atmosphere is the Met Office's HAD-GEM3 GC 3.1 atmosphere, which is the same configuration they're using in their CMIP6 runs. The difference is that Joules has been replaced by cable. So the land surface scheme is different, otherwise it's the same. It's got what's called an N96 resolution, 1.875 or 1.25 degrees, 85 levels. So the top level is at 85 kilometres. So we now have quite a good stratospheric resolution. This version of the model has much more sophisticated chemistry, aerosol, cloud interactions with the GLOMAP mode scheme. So there's a much more detailed treatment of aerosols. And as I said, it's only the physical model. There's no carbon cycle. It's based on version 10.6.1, which is before there was direct netset output. Direct netset output in the So we're still using the UM's own file format. The Oceans MOM5 on the same tripolar grid with 1 degree resolution as we used previously, with 50 levels. We've got SICE on the same grid as the Ocean. We're using the OASIS-3 MCT coupler, so that's a direct coupling rather than going through a separate OASIS executables. Now it's built into each of the executables. And for all the details on this, we're now pleased to say that Dave B's paper on the CM2 configuration has now been published, and so you can find that there. So that'll give you all the details on the configuration and the model spin up and the sort of the pre-industrial control climate. Now, our CMIP6 deck experiments were all run on Raijin and used the Intel version 17 compiler. With the move to Gadi, we've had to move to a new compiler. So we can't reproduce those experiments exactly because the compiler is giving us different optimizations. However, we've done tests that show these differences are no larger than you'd expect from just floating point round-off. So both short-term and long-term tests have convinced us that the model's giving us the same climate on Gadi as on Raijin. And just as an example, we've done a 200-year repeat of the PI control run on Gadi. That's showing you the global mean surface air temperature from both runs. And the mean difference in the temperature is less than you'd expect from the sampling difference of 200-year means. So we're happy that the runs are the same. And on Gadi, we've done some extra ensemble members of the SSPs, and you can see the thick lines of the original Raijin simulations, the thin lines of the new Gadi simulations, and again, we're happy that everything is within the sort of natural climate variability. So although we can't reproduce our original Raijin runs, we're happy that Gadi is working properly. So as I said, CM2 typically uses of order 1,000 cores on Gadi. We get about 4 hours per day. It takes about 4 hours per simulated year. So you can get a throughput of 5 to 6 years per day if you don't wait in the queue. The cost is dominated by the atmosphere, and the atmosphere also limits the scaling. So when we originally moved from Raijin to Gadi, we got about a 25% speed up on from the Broadveld to the Cascade Lake nodes. What's a bit strange is that just in the last couple of weeks, now that the Broadveld nodes have become available on Gadi, they seem to be running faster. And they're the orange, they're running faster on Gadi than they did on Raijin. I don't understand what's going on there, so that's still being investigated. But it does mean that the performance advantage of the new Cascade Lake cores is now very small. And so given the difference in the charging, you're much better off, it seems you're much better off using the Broadwell nodes on Gadi than the Cascade Lake nodes for running CM2. And it looks like, say, a 24 by 24, which is 578 core UMD composition with about 80 for MOM and 16 for Gadi, so about 700 core total is probably the best balance of cost and speed. So the experiments I've got running at the moment are using that decomposition on the Cascade Lake nodes. I haven't tried running any long runs on the Broadwell nodes recently, so I don't know what the sort of queue throughput is like on those, but certainly if you're going to run the model and you're at all constrained by your SU allocation, I think the Broadwell nodes would be the best bet. So onto the code repositories. The UM is using the Mid-Office Science Repository Service MOSIS. So there are CM2 branches in both the Joules and the UM repositories. There's a local mirror on ACCESS-Dev that you can use for building without having to go through the whole sort of registration thing. MOM, we're using the standard MOM repository. CICE, there's a local branch in the ACCESS SVN repository. And there is also some driver scripts in a local repository. So to use MOSIS, you need a separate registration process. And again, you can request that through the ACCESS help, which I'll mention later if you need that. So CM2 is controlled by rows, sort of a rows and silk. So the whole model configuration is in a rows silk suite. So this has the task dependencies, the whole build, run, post-process cycle. It has the build configuration, so what compiler versions you want, what library versions you want, what branches of the code you're using. It contains the model configurations, all the name lists, the names of the data files you're using. The suite contains experiment configuration, so the run length you want, which queues you're using, how big each chunk is, how many months you're running at a time. And the good thing about this compared to the old UMUI you might be familiar with is everything's a text file, so you can edit it directly if you like, or you can edit it with a tool called Rows Edit, which I'll demonstrate in a minute. We've got a few release suites that are available for everybody to use and have been tested that they don't depend on any CSIRO project files. So there's a PI control and an historical coupled model suite, and there's an AMIP suite. And to have a look at those, you can either just check out a copy using the ROSI checkout command, or you can make a copy of that using a ROSI copy command. And if you do that, this is what you'll get on disk. This is all the files in a suite. It looks pretty complicated. The good news is you don't need to worry about most of these things. I'll just go through and give you a bit of an overview of what's in the suite. So if you are modifying things, you do have an idea of what's there. So the overall suite control is in a rows suite conf file and a suite.rc file. I'll show you what's in those in a minute. So the build configurations, so the compiler options, the code branches are in these FCM make, or the configurations of the FCM make for the UM and the drivers. And also the MOM and the CICE builds are also controlled by the suite. So you can set which compiler versions, which CICE and MOM branches you're using, that's all in the suite. So the model name lists are set in the suite in these rows app conf files for the UM, MOM, and for CICE. So all the regular model name lists are in the suite. So the other advantage of this is because it's all in the suite and the suites are version controlled, you've got a measure of reproducibility. You can go back and be sure you can reproduce what you've run before. You know what the configuration was. It's not just in a bunch of files on disk somewhere. So at the startup, there are various tasks that install ancillaries, install various OASIS sort of grid files, install various files. And so there's some post-processing tasks. So one thing we've added recently is a task that will convert the stash output to netCDF. And Chloe will later be talking about the process for converting that netCDF into the final CMIP6 process netCDF. This doesn't do that, it just converts to a netCDF that you can use for your sort of analysis along the way. So some ways in which ACCESS-CM2 differs from a regular configuration. We've used the Gregorian calendar, and there are code optimizations that make that more efficient than the normal way that the uses the Gregorian calendar, because that normally requires dumps every day and a few other things that are quite expensive. So those optimizations mean that you have to run in multiples of full months, and you can only save monthly means from the client meeting. You can't save the seasonal or annual means. In practice, we've found that's not a limitation at all. We never use the seasonal means anyway, and you'd always want to run in multiples of months. Otherwise, you'd be having jobs in the queue all the time. The configuration still has the Joules name lists in it, though those are ignored. Not all the cable parameters are in the name lists. A lot of them are still, the cable PFT parameters, for example, are still in the cable code. The results are sensitive to the MOM decomposition. So they're not sensitive to the decomposition, so you get reproducible results if you change that, but the MOM decomposition does change the results. And the results are also sensitive to your restart frequency, whether you run in 3-month chunks or 6-month chunks. And that's due to both some MOM initialization and to some cable initialization. And finally, not all the control files are in the suite. So there's things like the OASIS name couple file and the MOM diagnostic table that are dragged in at runtime off disk from Gadi. So in principle, we could move those into the suite, but I guess we haven't yet. So this is what the suite will look like if you look at it with rows edit. This will bring up there's a bunch of suite configuration files that show up in the menu at the left. So for example, this page is showing which machine you want to run on, which queue you want to use, which core type. And in the file itself, you can see they're just text entries. So you could change those directly, or you could change those through the GUI. The advantage of using the GUI is that there is metadata behind the whole configuration that sets what the allowable values are. So for example, for the core type, you've only got a choice of 2. And some of the other, when it gets down to more complicated model name list values, there's some logic checking that you don't specify, impossible values for options. Similarly, there are build options, so you can choose to build all the components, run the model. If you're doing a rerun, you could use an existing executable, and you could switch the build off. Options for running the model, the length of the model run. We normally run in 6-month chunks. The chunks normally take a bit less than 2 hours. We have found that every now and again the model runtime does blow out for whatever reason. So the raw clock time is actually set fairly generously, so it'll still complete if that happens. That seems to have become a bit less frequent recently, but it was more of a problem earlier in the year. But I think it still does happen. We're not quite sure why. There's a configuration for the netCDF output. You can choose which streams you want to, which of the model streams, the daily or the monthly means you want to convert. You can choose whether you want to remove the fields files after the conversion. We're happy that the conversion does work and you're not going to lose any information, but at the moment, in this example, we're not removing the files as it runs. So the cable configuration that's in the There's various cable configuration options that are set. You can see the actual name lists there. An example of something you wouldn't want to set through the name list is something like, say, the CO2. You can see there's a whole bunch of, this is a historical run, you've got the CO2 levels for each year. And although they're in the, you can see those via rows edit, in practice you'd put those in via just a text editor from whatever data file you had, if you're setting up a different emissions profile. One thing we definitely do want to use rows edit rather than do it by hand is setting up the stash, choosing the output variables. The GUI for this is quite good. You can add new variables, you get a list of what's available, and then you can choose which time profiles and so on for each of those variables you use. So setting that up by hand directly is very error prone, so I certainly recommend using the GUI for that. This is what cylc shows for a graph of the model as it's running. The tasks with ellipses run on ACCESS-Dev, so the code is extracted from the repositories on ACCESS-Dev, the model components, sent across to Raijin, to Gadi, where the builds happen. So building SICE, building the building MOM, installing some files, then running the model. After the model runs, files are moved to an archive directory. There's some history post-processing, so running the MOM MPPN combined step, running the netCDF conversion. While that's happening, the next task runs. So this is pretty efficient. So this task only takes a minute or so. So in principle there's a very small delay between running the coupled model tasks, and these can run, and these post-processing tasks can run simultaneously on just a few cores. So the post-processing is quite efficient that way because it's separated from the main tasks. So the input file locations on Gadi, there are CM2 specific ancillaries, so our land CMASK and files that depend on our land CMASK, the access data directory. There are CM2 specific files, so restart files, OASIS grid definitions and so on, again under the ACCESS-CM2 directory. All the CM2 CMIP6 forcing files are in this directory. For CM2, we're using the same files that the Met Office used for their experiment. So these have been basically just downloaded from the Met Office. So there's historical and all the SSP ancillaries there. So that has things like the sulfate emissions, the other aerosol emissions, the ozone, volcanic emissions, and so on. Now, the structure of the running model on Gadi, once you start the model off, the files get copied across to Gadi. In your home directory, there'll be a suite directory. Some files are just copied from the suite on ACCESS-Dev. You'll have share and work directories, which will point to your project Scratch areas. And we'll show those in the next slide. And each task that runs has a sort of a time-stamped output in the log directory. So the coupled task is the standard output and the error output files. So if something goes wrong, that's where you'll look to see what's going on. So in the share directory, in your project Scratch area, that's where the build, so the files, this has the files that are needed from one cycle to the next. So you have the model build and some various data files. In the work directory, each model cycle, so in our case 6-month chunks, there are directories for those. So there's a coupled, it's basically the same structure as you might have seen with older versions of the ACCESS coupled model. So there's a coupled directory, and under that there are atmospheric, coupled, ice, and ocean run directories, each with their own history and restart directories. So you have one of these for each 6-month chunk. The housekeeping task prunes the old ones. You've only ever got a few of these on disk at a time, so that the data volume doesn't build up too much. And we have an archive directory that has the history and the restart files for each of the model components. So the restart files get copied from the archive to the work directory at the start of each cycle, and they get copied back again at the end. When the model's running, cylc has its own GUI, which will start up when you run the model, and that will show you the structure of the tasks. So in this case, the build tasks and the install tasks have all succeeded, and the coupled model task has been submitted, and these other ones are waiting for it to run. And from the GUI, you can kill tasks, you can stop them, you can resubmit them. It gives you a very flexible level of control. So if something goes wrong and something crashes for some reason, you can fix the problem, or and then you can resubmit the task from the GUI. From ACCESS-Dev, there's a cylc-review web service that lets you have a look at the task. This is very useful if you've got a bunch of models running, so you can check what's going on without having to log into ACCESS-Dev. So it's particularly handy for doing things from home. Got a bunch of AMIP suites running at the moment. If you zoom in on one of those, you can see the various time cycles. Everything's run successfully. And going into a particular cycle, you can see where the tasks have all succeeded. And you can see the job output files from the GUI again, which is a handy way to look at things quickly without having to log into ACCESS-Dev. Finally, just where you can find some extra documentation and help. This has obviously only been a very quick overview. There's an ACCESS help email address at NCI, which is seen by NCI staff, CSIRO, BOM and CLEX. So any access related issues should go to that. Any purely NCI sort of account problems should go to the regular NCI help, but for access related stuff, use this one. There's the ACCESS wiki on ACCESS-Dev, which is a lot of sort of getting started with access information. There's a CM2 webpage there. The CLEX CMS team have a wiki with a lot of access related information and getting started information as well. For related stuff, there's the MOSIS wiki. So all the MOSIS code and the documentation is there. Again, that has uses a separate account, which you'll need to apply for separately if you don't have one. cylc and ROSE themselves both have very good documentation. Their websites are there. So in the future, I guess we'd like to add some extra science configurations to what we're calling the supported release versions. There is a single column model version of the CM2 configuration with cable, which was very helpful in some of the development work. So I want to make that a supported release. The CM2 only has a very basic level of UKCA, which is just sort of enough to run the aerosol scheme. So Matt here is running experiments with sort of a full UKCA scheme, so we might make that a supported configuration as well, depending on interest. We've got some interest in adding cases with a higher resolution ocean and possibly also a higher resolution atmosphere if we can afford it. And of course, with the ACCESS NRI getting funded, I guess hopefully we'll have some scope to add some sort of better support across a whole range of things into the future. So thank you, and I'll stop there.
Thank you very much for that, Martin. I think I've covered most of the questions that have come through the chat function. If anyone has a pressing verbal question, type an exclamation mark into the chat function and I'll coordinate that. There was one from Abhishek, Martin, around where can we find the diag table, so the setting output diagnostics and input name lists. I think it's through the ROSE system, but you might want to...
Yes, so there's a coupled task in the suite, and that has a configuration file which specifies a whole bunch of coupler related things, and also it specifies where the diag table comes from. It's in the access directory. It's a copy of the one you set up, Arby, but it's now been put into an access sort of central directory. So that the path for that is in that couple task configuration file.
Martin. We'll keep moving on, and if you could take control of the screen, and we're going to go next to Tilo and move on to some detail around running the ACCESS Earth System Model 1.5.
Yep, ready for Tilo.
Short infotorial from Matt Woodhouse. So we can also run nudge simulations from both Era 1 and Era 5, and a call out to Plex, who support some of those large data sets on the NCI system, such as the new Era 5 download. Tilo, feel free to take it away.
Thanks, Simon. Good morning, everyone. I'm going to provide you an overview of the Earth System model version that we submitted to CMIP6. ACCESS-EMS1.5. I will keep this overview very brief so that Holger has plenty of time to talk you through the process on how to obtain the model from the repository and how to set up and run ACCESS-EMS1.5. So what is ACCESS-EMS1.5? As already mentioned, it's an Earth System model, so it includes physical processes just like those in a climate model, but it is also able to simulate the interactions between the physical climate and other biogeochemical processes. So ESMs are generally more complex than climate models because of the additional components that they consider. In ACCESS-EMS1.5, we have biogeochemical components for the land. This component is called CASA-CNP, and CASA-CNP is part of CABLE, the land surface model that we use. And for the ocean, we use MOM5. The same model is in the climate model version, CM2. But in the ESM, we have an additional biogeochemical component called WOMBAT. And just for completeness, I've also listed here the atmospheric component that we use is the the Unified Model from the UK Met Office. But in the ESM, we use an older version, 7.3, and the sea ice model is size 4.1. There's also a paper in JSHESH, the reference is given at the bottom of the slide, that provides a more detailed description of the ESM model along with its configuration and evaluation of the control run and the historical simulation. Next slide, please. So here you can see some more details around the setup and performance. The ocean model has a resolution of 1 degree, atmosphere and land a resolution of 1.875 by 125. So ACCESS-EMS1.5 runs at the same horizontal resolution as the climate model CM2, but the CM2 has more vertical levels in the atmosphere. The model runs are set up on the NCI on Gadi. In the standard setup, ACCESS-EMS1.5 uses 384 cores. Half of those are assigned to the atmospheric component. Computational costs are about 1.1 kiloservice units per year, and it takes about 1.5 hours for one simulation year. So if you don't spend any time in the queue, you can have a maximum of 16 simulation years per day. You can also run ESM in atmosphere only mode with prescribed sea ice and sea surface temperature. And if you continue to use or assign 192 cores for the atmosphere, then it doesn't run any faster, but the costs are only half of those for the coupled model. I also stated the climate sensitivity here, the equilibrium climate sensitivity, ECS, because there has been a lot of debate around this recently. A number of CMIP6 models show a very high climate sensitivity, over 5 degrees. So ACCESS-ESM has an ECS of about 3.9 degrees Celsius. And to put that into perspective, the CMIP6 range is, I think, around 1.8 to 5.6. So ACCESS-ESM sits somewhere in the middle of that range. Next slide, please. So here you can see a summary of our contribution to CMIP6. It's a huge effort. So far, we set up and run more than 40 different experiments, and that amounts to more than 10,000 simulation years, producing more than 0.5 petabyte of raw output. But it is reassuring to know that results are being used by the international community. So far, we had more than 2 million downloads for our model from the ESGF. The ESGF is the Earth System Grid Federation, where all the CMIP6 results are available. We participated in 8 different MIPs, which are listed here. So that's the scenario MIP, comprising 4 different future scenarios. C4 MIP, the coupled climate carbon cycle MIP, ZEG MIP, the zero emissions commitment MIP, CDR MIP, the carbon dioxide removal MIP, DA MIP, detection attribution MIP, the radiative forcing MIP, and PMIP, the paleoclimate MIP, through the University of New South Wales. And currently we are also running experiments for the COVID MIP to explore the impact of recent emission reductions. You can see by the choice of MIPs that we're participating in that there is a large focus with ACCESS-ESM on carbon management and exploring the impact of emission reductions and carbon dioxide removal. And these are certainly areas where we see a lot of potential for future applications for ACCESS-ESM as well beyond CMIP6. Okay, I will stop here and hand over to Holger, who will show you how to run ACCESS-ESM.
Very much, Tilo. If there's any questions for Tilo, put an exclamation in the chat function. Otherwise, we're going to Holger. So a little call out to NCI. Just this work would not without NCI, including the Australian node of the Earth Systems Grid Federation, which they've taken on over the last few years, where we publish all our ACCESS CMIP6 results out to the world. So fantastic support from NCI for this whole project, and fantastic support through Plex from the CMS team. And I just wanted to have the link to the GitHub repository where it's fully documented how to get started on the ESM model, and we'll pass it over to Holger now, who will take us through a brief training on that. Thanks, Holger.
Hello, thank you very much, Simon. Thank you, Tilo. It's good to speak to lots of you again. Let me share my own screen. I hope that you can now see a GitHub page. Is that correct?
That's all. Yes, we see your screen. Thanks, Holger. Go ahead.
So this is the web page. This is the GitHub page you will see when you click on the link on the slide that Simon has just presented. So it's github.com/COE-CMS. That's our team. ESM-pre-industrial. And this is both. There's both the configuration, all the configuration files, and a README that describes on how to run this model. So as you can see, this is the pre-industrial version. We have some others, but this is the easiest one to get your head around. So I'll just start with that, and if you have more questions, we can talk about that some other day. As you can see, it's on GitHub, so it's all under Git version control, which is actually quite convenient because the model itself keeps track of all the changes that you make. Every time you run the model, it creates it automatically creates a snapshot in the repository, so that you can always go back and see what was the configuration that I've run this under. So let's go over to Gadi. The way that we recommend that you do it is you would first create in your home directory an ACCESS-ESM subdirectory, and then you would want to check out this repository. In case you have never used Git before on Gadi, you need to run these two commands: git config -- global user.name and then your name, and git config global user.email and then that's exactly behind the screen here. So this is every documentation about Git will always tell you to do these two things, and you need to do that in order for it to run. And then you go back to this and you click on this link here up here. Click on HTTPS. That's what I would recommend. For starters, it's easier. And you copy this link. You can just copy this by just clicking on this button. And then you just type git clone, and then you paste this link, and it will automatically clone everything into a subdirectory called ESM pre-industrial. So if we go in here, we can see that everything all the files that are here are now also in here. To run PyUp, you need to load the module Conda, our Conda module, which is available when you use module use g data public, no, hh5 public modules, and then module load Conda. Again, this is also described. That's also described here. Oh, this is still using the unstable version. You can use the stable version by now. And PyU is configured mainly through this config.yaml file. So if I just look at it, it's actually reasonably intuitive, I would argue. It has a job name. You can tell the queue. You can tell the wall time. Actually, 3 hours, 10 minutes is a little bit. Is there no? Cursor has a weak color. I don't know why that is. That's actually still from Raijin, where we needed 3 hours. We don't need that much anymore. The laboratory is basically a directory. You see here if it's a relative path, and this is a relative path because it doesn't start with a slash. It's relative to Scratch project user. Then model access. That's basically telling PyU which model you're running. And then it has these submodules where you declare your binary and the number of CPUs and where it should get its input files from. And the same for ocean, ice, and the coupler. So because it uses MCT, it doesn't use any CPUs for that. Collate is something to do with MOM. I don't quite know about it. You should ask someone about what MOM what that means. Where the initial start files are. And then here you have calendar and then the runtime. So this is configured in such a way that every time you submit something to the queue, or every run is exactly 1 year. And yes, I think that's all the configuration of PyU. And then the submodules are configured in these subdirectories. So you have one for atmosphere, ocean, ice, and the coupler. So if we look in the atmosphere, you see all the normal. Sorry. Let me quickly grab something to drink. You see all the normal configuration files for the and that is actually a little bit confusing because I think all of these files they are actually, I think, ignored. But I'm still editing them anyway. But the important file is this one, the _env.py, which, if you look, is just a Python dictionary for all the environment variables, shell environment variables, to be set when you run the model. So you can see that certain input files are here. This input here, the capital input, just refers to the input files that were configured in the main configuration, the config.yaml. You can see that you also have to set the decomposition here. So you still have to double check that your PyO configuration is consistent with the model config, with the submodel configuration. And the other one is the other interesting file is, where's my mouse, is name lists. This one here, and that is literally all the name lists from all the other files just put into one big file. So you can see that's just lots and lots of files, lots of name lists. And in order to run it, what you do is you simply type if you've configured everything, you simply type PyO run, and that would submit a single year to the queue, and then it will calculate that. You can't say it. I want to run. So if you want to run, for example, for the next 40 years, you would say PyO run -n and then 40. That would create 40 that would resubmit to the queue until it has calculated a total of 40 years. And then next time you want to calculate, if you want to then say, okay, I want to calculate another 20 years, you just say -n20. So this is always in addition to what you already have. If I'm not going to do this quite now, but if you want to see how PyO sets up the system, you can run PyO setup. That will simply set up all the files in the work directory. So if you look at here, it has now created a work directory which is actually on Scratch, even though it's linked in your home directory. It's actually on Scratch, or wherever you've placed your laboratory in the configuration file, and it will have copied or linked all the input files. So, for example, for the atmosphere, it has created, it has linked the restart dump. It has the name list files. The name list file is here. Everything. If the model crashes, or if you've run this PyO setup, you shouldn't run this PyO setup yourself in preparation for a run. You can run it to see to make sure that the setup is correct. But before you actually run it, you need to do a PyO sweep. PyO sweep basically cleans up after a crashed run or after a setup to just prepare to make a clean environment for the next submit for the next run. How am I in the time? I'm not quite sure.
Keep going. You're going fine.
I'm going fine. Okay. We have in this config file, we have a setting down here that was actually pretty useful for during the times of Raijin. I'm not sure how important it is now. Runs per sub. So that came out of the complaints by several of our researchers actually, who would wanted to calculate to have an experiment, and their experiment would be sitting in the queue for 24 hours and then run for an hour, calculate a year, and then sit in the queue for another day. And so what you can do is you can increase the wall time up here, and then update this, make this number larger, and that means that it will automatically try to run it as many times in a single submit. So it will always restart the same way as it would if you don't do it. But after it has finished the calculation for a year, it will then not give up on the running job. Instead, it will restart for the next one and the next one, the next one, for however many subs you have. So if you have, or until your requested number of runs is exhausted. So if you, quickly check something. Still running. So let me have a manifest. Yes, manifest. I said that every time you submit a run, what it actually does, it also creates, unless nothing has changed, it will also create one of these submits here into the Git repository in your local one. So it doesn't push that to the remote one, but in your local one, you get these local submits. So for day, time, and will then say run 0, 1, 1. And that way, if you could simply go back in time to this snapshot, and then look at what was my configuration. So okay, so back then I still had a project here, not much. Anyway, so I can always go back, and I can also look at the manifests. The manifest basically contains 3 files, and they have they tell me for the executables, the input files, and the restart files, which the full path of the file that was used, but also it creates an MD5 hash of each of these files, and this can help you to verify whether whether the file that's still there. So I could just run an MD5 sum on this file and then compare it to this number. Pointing at the screen, of course, I'm pointing at the screen, and then compare it to this number to see whether anything has changed. So we can do this for. So if I go this and I see okay, so this hash starts with B940, and so okay, so this is still the same executable, and the same goes for the input file. So input YAML, of course, there are far more files, but you cannot recreate them if they differ, but you can verify that they're still the same file. And you can then go back to the latest one by saying git checkout master. I'm using CO here, by the way. That I shouldn't do this. That's an alias, so the correct one would be git checkout master. So that would work. Okay, so here you can see that this job is currently finishing. So I've just started one a little bit earlier today. And when it's finished, it will create it will have these if it finishes normal, then it will put the logs in archive. Let me quickly check something, because it's currently, as you can see, it's currently in the process of starting a new one. Okay, so it has now. So this model has now run for a year. So I've started this morning, and it has. So if you look at it has also created this archive link, which is also a link to Scratch. And you can see that there is restart 000. This is what tells PyU. Not only are the restart dumps in there, but this also tells PyU how far into the job are you already. So it looks for the latest one there, and that is where it will run for the next time. And then archive output 000, and then you can see that there's again atmosphere, ice, and ocean. So if I look at the atmosphere there, you can see all these standard output files. So this is where the data would accumulate. These files should then, because the job should have run through cleanly, they should be moved to archive/pbs logs, but it's currently probably doing that when the next job starts. Yeah, so it archives the logs in. Should archive the logs. Anyway, yes, I think that is the quick and dirty overview about PyU. I think this is about how much I've prepared, but there is, if there are any questions, please ask them.
So thanks very much for that step through, Holger. If you have questions to ask, please put an exclamation in the chat function. Ryan did comment, first of all, it's great that CMS and PyU have picked up the ESM1.5 model. The example you've given us is the pre-industrial, so I'll ask Holger, is there going to be the scenarios, the basic set of scenarios and the historical run, etc., provided as templates also?
So we have, wrong direction. We also have we have some others. So ESM historical here. It's basically the same thing, except that for the historical we still need this warm start, which updates the ancillary files to point to the correct year, which otherwise the would complain that the files are out of date. We have some others, but you can feel free to modify if you want to. You can modify them. Well, so at the moment, the latest one that we're working for is PMIP last millennium. That's the one. Yeah. So that was actually a slightly more convoluted project, because we had to also create new binaries and stuff. But there are some other configurations. But also, yes, it should be reasonably easy to configure. The main issue that we always have is trying to keep this all binary reproducible with the version that CSIRO was running. So that's most of the work. I think once you check out the pre-industrial run, it should be reasonably straightforward to adapt it to your experiment.
So that's a very important point that Holger makes to everyone. ACCESS is a community model. GitHub is a community coding system. Anyone can get in there and build on this system as well.
Yeah.
Ryan's question was around whether CM2 would fall under PAYU. I had an attempt at answering it, but Martin, do you want to comment on perhaps why it would?
No, the UM is very tightly tied into rows and cylc. It'd be a lot of work for I don't think any real gain. Yeah, I don't think there's no prospect of doing that. I don't know whether it would even be possible, but I've certainly got no interest, and I'd recommend against anybody trying it.
That's a no to Ryan. Thank you, Martin.
Yes, it's a no.
So Paul Leopardi is asking around future development of ESM models. I think Tilo is best to approach that. I'm sure there's lots of future development planned.
Yes, there are plenty of plans on what we want to do and where we want to go with this, but there's nothing finalized. And with the ACCESS NRI now confirmed, that opens up a whole lot of discussions and possibilities. So we will see where this leads to. But certainly we want to continue the work that we have done with the ESM.
Siobhan raises a question, Holger, around PAYU year numbering in the archives, whether that has been addressed or fixed.
I'm not quite sure what the question is about it. So let me share this. I just switched. I just canceled the share. So archive output 000 atmosphere. So I'm not quite sure what your question is about the year numbering.
Okay, it basically just goes to 1 year and it goes to 00 and lots of numbering. While we in the SARO system, we basically put the original year into the files as we output in our original Q subs for the ESM model and the old ACCESS models, and obviously the row silk system will have the years automatically. So at some point you have to, when people are trying to work with the files, they're not as easy to work with. When I've tried to work with the stuff of the Cosmo model,
Yeah, I mean, they're not as
easy to work with as a Cosmo output as our output. So that was just my comment.
No,
but obviously
it doesn't work on it. PAYU is at the moment does not automatically rename stuff. Yeah. The thing is, if you let's see somewhere. There is a PAYU.readthedocs.io. There is some overview about how PAYU is used, and there is some sort of post-processing where you can say there are certain flags you can use in this config.yaml file to run certain scripts before or after the model execution, and so there is nothing preventing you from creating a script that renames files according to what you want, and then simply running this very easy, very simple, and very quick script at the end of each model run.
I mean, I know Andrew Kiss and Russ Fiedler has certainly changed some of the system on the Cosmo system, so it now does have year numbers in the files. So I was just wondering, I mean, it's obviously a simpler system to run than RoSilk. And simpler than our old one scripts. You obviously tidied up all that, but it's still got this slightly clunky in terms of the output.
We went to PAYU because we found the original way to run the ACCESS ESM models with these KSH scripts quite confusing and found it hard to explain that to our researchers.
Yeah.
And
I know those scripts, so I mean we use them. We use
so,
them.
but PIO is nowhere near as flexible as rose silk. So that's also why I suspect that newer versions of ACCESS ESM will, especially when the UM version supports rose silk, will probably be used with rose silk and not with PIO anymore. But if you want to run ACCESS ESM1.5, then I would strongly recommend using this PIO version instead of the scripted version.
So I just want to comment on the structure of the output files there. One thing I'm planning on doing in the near future is putting together little set of tools that could be used for a range of different sort of access analysis type things. And one of the scripts I'm going to put together is a script that will go through these output structure with this funny naming scheme and create something that's a bit easier to read, something that looks like CM2. So it's on my books to do.
Yeah.
Thanks, Chloe. I want to just touch on David Caroli's question about if we were advising a new student or postdoc coming in to learn the access model, which would be the best model to choose from. I think there's a lot of questions, David, there. One is resourcing. Obviously, the latest couple model is much more expensive. Two is science focus, whether you would need biogeochemistry and carbon cycling in the system. And for a lot of scientific questions, you would. Tilo, it'd be very good to speak to that. But yeah, maybe Tilo, if you want to add a comment to David's question.
Well, I guess it depends on your needs and what you want to look at. I mean, the ESM covers the physical side as well, but it has an older UM version. What's also interesting and worth mentioning is that both models have a different climate sensitivity. So again, that provides us lots of opportunities to look at different things. With regards on what model version you choose to run, it's entirely up to you. There is a lot of experiments already available, and Chloe will speak to that in a minute. So maybe the first step is to have a look at what output is already available, and then go from there and see if you want to design your own experiment or what type of research you want to do. There is no straight answer, you should run this model or that model.
Thanks for that. Obviously, there could be more discussion, but that's a nice segue into Chloe's presentation on the CMIP6 datasets. So I'll hand the floor to Chloe now. Thank you.
Sorry, can you hear me now? Yeah, my internet's been a bit shocking for the last little while. So I'm just going to talk about the ACCESS datasets that we have available for CMIP6 on the NCI and the ESG, but I'll also cover some basic use of CMIP6 datasets as well. So a couple of things I can talk about. Once my screen catches up to me. So a quick summary of the datasets that we have produced for CMIP6 with ACCESS. So I'm covering here the scenario, the deck runs, which are under they just call it CMIP. Is the deck and historical. So we've got the PI control, some idealized 1% CO2 increase, about 4 times CO2 increase experiments, the AMIP, decoupled atmosphere only experiments, the historical from 1850 to 2014. And then these two here, the ESM PI control and the ESM historical, are the same as the regular PI control and historical, but run with interactive carbon cycles, which is the ESM functionality that we have, which is the extra 2 experiments. We've done a range of ensembles for the historical and for the AMIP. With the PI control, we've got quite a lot of years run for them. For with the ESM was something we did recently, which is a very long 1,000 year run to try and reach there, if that's interest you at all. The scenario runs, we've got the 4 different main scenarios, the T1 CMIP6 scenarios that we've run with both models. More ensembles with the ESM simply because it's been cheaper and easier to run larger ensembles with the ESM. Particularly with the SSP245, we've run up to 30 ensemble members now, not that all of them are available on the ESG. Same with the historical, actually I believe there's 20 now available. So that's sort of a brief summary of what we've got available, how many different ensemble members. If you're looking at doing large ensemble means, then the ESM might be interest to you, or if you're looking for sort of more state-of-the-art aerosols, things like that, then the CM2 smaller ensemble size books. Yep. We've also got some additional MIPs that we've submitted to that Tilo covered briefly. C4 MIP, some carbon cycle ones, that they do reversibility experiments under CDR MIP, the paleoclimatology PMIP, RF MIP is the radiated forcing, whereas it's a decoupled atmosphere only experiment. DA MIP, which is quite similar to the RF MIP with the different focus, and that's coupled. Those are a couple of historical scenarios. We've finished DA MIP with the ESM, but we're still working. We're still running them all with the CM2, so they're still in sort of production. One that Tilo didn't mention is FAF MIP, which is an ocean-focused MIP that Abhishek has run and put together. There's 7 experiments in that. Don't ask me what they're studying because I don't really understand, but I would get happy with that. With the OMIP, the original plan for OMIP was to run either the CM2 or ESM, was to run the OMIP experiment. However, it's been separated out, and CLEX is now using the Cosmo group is now using OM2, which is the the ocean sea ice coupled model, no atmosphere, and the OM2025 model, which is the quarter degree. And so we'll be running the Cosmo group will be running the models for the OMIP scenarios, one for each of them, I believe, and they're in production as well, undergoing some testing. Our most recent experiments have been the COVID MIP, which Tilo mentioned briefly. It's going to involve many, many ensemble members, so there's going to be sort of a lot there to dig into, if that interests you at all as well. So we've got quite a few experiments and different data sets available. This is just with the ACCESS. Brackets here are ensembles that are still in process of being run, published, and all that. Our data is all available on the NCI and through the ESGF. Through the NCI, you can you can get the CM2 and ESM datasets through the FS38 project. You can sign up to that into the through the Mancini portal. Once you get access to the FS38 project, which shouldn't be any problem if you've got NCI access, then you can get all the datasets. All of the other CMIP6 models, NCI is running a replication node through the project OI10, where they're replicating a lot of data sets from CMIP6, not all of them, because there's a lot of data out there. However, you can request particular data sets if you'd like to access them as well, and they'll get downloaded. Otherwise, you can access everything that's available on CMIP6 through the ESGF. There are a few different portals. This is the NCI specific portal, but I've got some links at the end to the more generic one, where you can it's essentially drop down boxes you can tick and sort through all the different models, experiments, variables, all that kind of stuff. As you can see, we've got quite a few data sets currently. Yeah. I want to highlight a few various things. We've got a website on research.cyro.au/access, where we're listing some specifics of our access runs, especially for CMIP6. I've got a special CMIP6 page and some connecting pages listing with a whole bunch of links and listing a whole bunch of document information related to our runs. A lot of the specifics that are covered here are available in some different tables. So I'm making sure that I'm keeping that updated. I updated it yesterday, so it's all up to date there, where you can track, you know, what's available, what we've got, which experiments, and details of the experiments. We've got version details, just overview details of the two models, although you can find more details otherwise. Links to many different aspects of CMIP6, which I'll also cover. Some generic CMIP6 tools that I want to highlight, not just directly access related. One I wanted to discuss, and I thought about this last night, I chucked it in this morning. I wanted to highlight the errata service. So it's we call it the errata service. It's through ESDoc, which I don't really know how to describe what ESDoc is, but they run the errata service and some model documentation as well. I suggest if you're using CMIP6 data, I strongly suggest that before you publish or make any final conclusions based on any CMIP6 data, you check the errata service to make sure that you're not using any data that has been retracted or has any known issues. The errata service has been quite good. We've had to use it quite a few times. As you can see here, I've got an example here of a retraction we put through just last week or the week before, where we found an issue with some of our 6-hourly models. They list exactly which data sets they affect, including the version number, which is the most important part. Make sure that you're always using the latest data sets available for the variables that you're after, and that you check and make sure that what you're using, if it has any known issues, that you're aware of them, or if there's been any retractions and republications, that you update to the most recent data. I think CMIP5, the errata wasn't handled badly, but it wasn't quite as easy to access all of the information, and CMIP5 can then be sort of easy to use data sets with known issues and not be aware of them. This ESDoc errata service is to try and help with that, to make sure that everything you're using is up to scratch and up to standard. We're lodging retractions as soon as we find them. If you do find any issues with CMIP6 data, including ACCESS, particularly with ACCESS, but with other models as well, please do let us or the institution know. We can't check and find every single thing, and I've been, a lot of good resources for tracking this information and finding anything that's gone wrong. So that's my strong plug for the errata service. Additionally, on Gadi, there is a tool called Clef that has been developed by ACCESS and Clex. It's a Python module that you can easily load up and run. What it does is it searches for all of the climate data that NCR has access to, including CMIP6, 5, and 3, and also non-CMIP climate data as well. Not that I've only used it for CMIP6 data anyway. I've got a link here with some documentation. It's very easy to use. You can search by different flags here that you can use, whether you want to restrict to data that is currently available on NCI. You can request the NCI to download CMIP6 datasets that aren't currently on NCI. It's a very powerful tool. So I really suggest using it if that's what if you're looking for lots of CMIP6 data. Here's just a quick example where you can specify a range of different. Activity here means the MIP, so we're talking CMIP, we're talking DEC and historical here, RF MIP, DA MIP, all that kind of stuff would change here. You can search by experiment, you can search by model, you can search by institution. Source type, this is atmosphere and ocean global circulation model. You can search by variable and table. There's many different parameters that you can search by to make sure that you get the right list of files that you're after. For files that are available on NCI, it will give you the full path to the version number. Inside this version number will be all of the files broken up into yearly chunks if required. For any data sets that it identifies that fits your search parameters but aren't available on NCI, it will give them to you separately in this format here, with separated by the dots. For reference, the different terms here, all the different aspects of the DRS are given down here. They're very specific and they mean very specific things. And I've got some links at the end if you wanted to, if any of these were confusing you, or you wanted to find out more information about different experiments and different institutions and things like that. I've just got a page with, I tried to just find as many useful links as I could. We've got the DARZ dataset citations. These are the official dataset citations that you'll want to use if you're using any CMIP6 datasets in any publications. I've linked the main CM2 and ESM here, which are the CMIP, so the Deccan Historical. The search function within the DKRZ citation sort of service is not very good, so you're better off just sort of estimating what the URL is. However, I've also included a link here that includes all of the citations to all the different MIPs and models. So sort of a quick reference if you need it. The ESGF, the ENCI run their own Australian-based model node. I think it's the only node in the Southern Hemisphere, at least in Australia, where all of the ACCESS datasets are available from. And there's also the main node. The synchronization between the NCI node and the main node is a little bit delayed, so not everything is available sort of on both. So if you're looking for ACCESS-specific datasets, you're best off using the NCI node. If you're looking for other non-ACCESS related datasets, the main LNL node might be the way to go. Some generic, so basic dataset info. We've got the data. I've got DataQuest link here with a lot of information on the different variables. If you're using any CMIP6 variables, I recommend knowing exactly what they are and what various groups have done to create those variables, because it's not necessarily as straightforward as it seems sometimes. I've got a link here that will give a lot of details of the control vocabulary. CMIP6 uses some really strict control vocabulary, so the words really tie down to very specific definitions throughout a lot of the CMIP6 datasets and metadata. So if there's a really helpful link for understanding what it's referring to. And I've got the URL link again. For some model documentation of the ACCESS models, as I said, the ESDoc group are run not only the errata service, but the model documentation service. Model documentation, we've had some issues and it's not exactly up to date. However, you can find them through these GitHub hub links, where you can find a lot of the model documentation information set out in fixed spreadsheet form that we kind of were given and sort of filled in all of the details related to the different models. I've also got some links to the model description papers, the one that Tilo's first author and the one that Dave B's first author for the CM2, just to add them for completion. One last thing I'm going to mention is we do have an additional document that will go along with this slideshow and some model release information, with a document that has been put together originally by Roger Bodman and Peter Dobrohotov, and I've updated and made sure it's up to date as far as Gadi and all the recent developments with CMIP6. It'll go through in a fair amount of detail how to set up and get going with ACCESS. And so it's a very good tool, especially if you use it in parallel with Martin's notes in this slideshow, which are also very good. And I think if you have both of those going, then hopefully you won't have any too much troubles getting CM2 running. We don't have anything similar for the ESM, mostly because PyU is a recent addition as opposed to Rose and Silk, which we've been working with for a while. So if you're using the ACCESS ESM, I recommend you use PyU, and the GitHub has a lot of information as how to get started with that. But this is to basic overview of how to get started with ACCESS-CM2, logging into Gadi, getting ACCESS Dev running, all those kind of details. And there's just some of the collaborators that we've been working with, and that's it. That's all from me.
Thank you very much, Chloe, and thank you all our speakers. David Crowley was asking around separation of ensemble runs. Tilo pointed out it was 20 years apart in the pre-industrial control to spawn those ensembles. I think, Martin, it was 50 years in CM2?
It's 50 with CM2.
Yep.
Because we haven't done as many, we haven't had to care. As part of the porting to Gadi, I did some tests on how quickly runs become independent. Even quite deep in the ocean, things are, the RMS differences are essentially saturated after 10 years. So 20 years is, seems to be plenty to get pretty strong, pretty good independence.
And Thomas Moore was asking about aspirations to store the data in the cloud. I don't think we're driving anything locally, but Claire did comment that that may get picked up through other nodes. Thomas, is that your question?
Yeah, that's great, Sam. Just wanted more also just to make people aware of it.
Thanks.
If people that were at C3 DIS a few years ago would have seen the UK Met Office people talking about, you know, where they're moving in terms of compute and storage, and it's all cloud. So it's just a long-term strategy so that our workflows remain relevant with future best practice.
Thank you, Thomas. It's been a pretty technical session today on getting started with these new models. The development's been going on for 5 years under the NESP Earth System and Climate Change Hub under projects 2.1, 2.5 and 5.1. So we're very grateful to the NESP backing on this and the CSIRO support as well and other community support. One question that a couple of people have asked recently is when's the next Access Science Day, so we can start talking about the science with the models. If you like to interact with Y or an N in the chat function, I'll run an instantaneous poll on whether you think we need one this year or early next year, given in mind the year's nearly over. AMOS is coming up early in the new year. There's a Plex workshop in Feb for a week. There's a BOM workshop also in Feb and a UM users workshop in February. So if I see a lot of Ys in there, I'll take that as a community demand that we set up another Access Science Day in the not too distant future. Is there any other general questions to any of the panel? Please whack an exclamation mark in the chat function. I think you know how to get in contact with all the speakers today. If you have more bespoke or technical questions you want to follow up with. Otherwise, we're coming to the end of our time. So I thank the speakers once again for all the work behind this webinar and putting together the presentations and collating a lot of useful information into a slide deck, which will be made available, I think, through the NESP Project 5.1 page, but I'll try to advertise that around to the various partners where both a recording of this session will become available and the slides from this session. So anyone feel free to just jump in and speak up if you have something burning you need to say. Otherwise, we'll draw it to a close. And thank you all for coming along today.
Is that it?
That's good. They're deep participating nicely, or scurrying off to have their lunch. Thank you, team. That was a good job. Harun made mention of it in the quarterly reporting that we've made some release efforts.
Yeah, I think this. So, do you want to write a couple of lines or whatever for this meeting for the report, Simon, or start?
Why don't you have a first crack at that, and I'll
Okay, that's fine.
because
Yeah, I'll just just include it in the report.
Just remind us of the deadline for the report. Is that this week before the
yes,
holiday?
so they said 23rd, obviously.